Hey everyone, this is William from Skycoin. I'm here today with Synth, and we're going to talk about Skywire, answer all of your top questions. First, we're going to start with some basics, and then we have a list of questions that we've compiled from the community. So first and foremost, Synth, what is Skywire?
So basically, Skywire is a new networking protocol. So it's just like plumbing for the internet. Like if you use Facebook or YouTube, you don't know, the user doesn't know, am I using TCP? Am I using UDP? Am I on Wi-Fi? Am I on Ethernet? Is this using border gateway protocol? The user doesn't care. These networking protocols basically sit in the background, and they handle all of the world's data and traffic. And so what Skywire is a new networking protocol for Skycoin that replaces a lot of the previous networking protocols. So one of the things that we wanted in Skycoin was we wanted to create applications that people used. So Bitcoin, for instance, you run a miner and people are getting paid hundreds of thousands of dollars for producing a block. But in Skycoin, we figured out how to produce the blocks for pennies. We didn't have to give all these people, $500,000 to produce a block for Skycoin. So we then had this problem, which was how do we distribute the coins? And what we decided was that the people who get the coins should be the people that are contributing to the network. They should be doing something useful. And so then we started looking at different applications, and one of the things we wanted to do was an incentivized mesh net. So we wanted to build a new internet that basically a peer-to-peer internet. So instead of having a utility company like Comcast, we would let people, that was centralized, we would let people own the equipment, and they would provide services to each other, and we would measure who was consuming and who was producing. And the people who produced bandwidth, the people who run the infrastructure, they receive coins, and the people using the infrastructure, who probably won't even know they're using it, will pay coins. So this is, Skywire is one of the base layers of the Skycoin ecosystem. So we have like CX, which is our programming language, and video games on CX, and we have CXO, which is our distributed object system. So it's more general than a blockchain. It lets you store anything. So you might want to tweet or post a video, and this lets you do that, but without a third party. So you actually control your own data, and it's replicated peer-to-peer. So if you have 500 friends that are subscribed to your feed, the data will replicate between them, and so you don't need a web server. And so the idea behind CXO is we want to have Twitter on blockchain, but we don't want to store everyone's tweets on the blockchain, because if you have 1 billion people, you don't want to download the tweets of 1 billion different people whose tweets you don't care about. You might only have 5,000 friends, and you only want their data and the data you care about. So we created, we don't want to shove all the data on a blockchain, one giant blockchain like Ethereum did, because it just bloats the blockchain into hundreds of terabytes. So we created this thing called CXO that is like a blockchain, but it's more powerful. And then we have CX, which is our programming language for video games and applications, and like messaging apps and things that people want to use. Then we have CXO for storing data in like feeds, social media, and we have a app called BBS on that, which is a decentralized social media platform like Steemit. That's the sort of embryo or a prototype of bigger apps that we're going to build in the future. And then we have Skywire, which is our networking protocol. So all of the data, the CXO data, the Skycoin data, the Skyledger coin data, all of that's going to be going over Skywire. So what we might have 1 million blockchains on Skyledger allows people to create their own blockchain. So each company will have their own blockchain. So for instance, a company in Portland, Oregon, a power company came to us and they want to do a blockchain pilot. So they say we have 300,000 people and we need to do this many transactions, per hour per person, and here are our requirements. And so they might have a blockchain for just a region or a city, and then when that's done, they might want to have 30 other blockchains, and they want to control the blockchain too. So if there's a problem, they want to reset it. And so we created this platform called Skyledger to allow companies to build their applications on blockchain, and then the data for that blockchain is stored in CXO, and the programming language running it will eventually be CX for all of their contracts and things, and eventually even the base software. And the hardware for that will be the Skywire miner, which is our hardware platform. And then Skywire is just the networking protocol that all of these applications use to communicate. So CXO is computation, CX is computation, CXO is file storage, and Skywire is communication.
So focusing on Skywire then, how does it overtake the current internet, and can the existing internet be accessed through it?
Yeah, so the current internet is pretty old. It actually dates back to the 80s. And it was created completely ad hoc. When the internet was first made and was gaining adoption, the best protocol didn't win. It was the protocol that had the most users and that was easiest to use. And a lot of the protocols had really good features or superior to the protocols that prevailed. But now, as the internet's growing to 6-8 billion people, it's hitting problems. The current internet protocols can't do everything that we want to do. So, for instance, if you're downloading a movie, you want the connection to be fast, but you don't care if the packet takes 5 seconds. But if you're playing a video game, you want the lowest latency, and that's called quality of service. And so we want, depending on what you're doing with your computer, you want to have different criteria for the data. And the current internet doesn't support that. But if you're a surgeon and you're operating a medical robot, and the surgeon's in India and he's operating a robot in the US, and some packets drop for 2 seconds, that's a problem. And if the latency is high, that's a problem. Or if the latency is variable, it's a problem. Or if you're in a video call and it drops, it's a problem. But if you're downloading a movie and there's like on YouTube, and there's a 2-second gap in the data, it doesn't matter that much. The user won't even notice because it's buffered. So there's these different things with the current internet that we wanted to improve. And so there's several problems with the current internet. One of them is people are not paid for providing the infrastructure. So the companies, the internet is basically consolidated into a few monopolies because the way that the providers are paid is they're not paid per unit of bandwidth. They're basically paid, let's say you have a co-location and 2 internet providers. They'll have an exchange point and they'll swap cables they'll connect cables to each other, and they have a peerage agreement. So they say, I'll take your traffic and you take my traffic. And then Comcast comes in and says, we own 150 million households, and if you want to get access to our people, you're going to pay us. And then these little companies get basically shaken down and eventually driven out of the market. So what we see now in the U.S. is we had 1,000 telecom providers. Now we have Comcast and Time Warner, and they tried to merge into one mega company. And they were stopped, but they're eventually going to get that merger through, I think. And you're either a Comcast town or you're a Time Warner town. And that's because of the way that the payments for bandwidth are done. So we wanted to, so over time, you start with 1 million companies, and then you get 1,000 companies. Then the market consolidates into 1 or 2 monopolies. And then the monopolies become so abusive that the next thing comes in. So like when Bell Telegraph became the monopoly and they were pushing people around, then the next thing comes in, and then you have the internet and the new way of doing things. And so this is a cycle. In any industry, you start with 1 million companies, it consolidates into a monopoly eventually. The monopoly becomes abusive, and then the new technology has to be rolled out, and that becomes the new foundation for the next cycle of innovation. And so what we're trying to do is solve the payment problem, making sure that the small ISPs are getting paid. We're trying to build internet protocols, networking protocols that take advantage of like wireless networks. Like we didn't have 6 gigahertz point-to-point access, chips that cost 30 cents. We didn't have these Wi-Fi chips with like 8 antennas in them that cost $1. That didn't exist 4 years ago. So if you were trying to build like a mesh net, which is what we're trying to do with Skywire, and you tried to do this 10 years ago, the hardware would have cost millions of dollars. And now it's in every cell phone, and it costs pennies. So the technology is now ready for this new type of internet, and if there's no applications, like if you're not doing robotic surgery where the surgeon is in a different country than the robot, you don't need quality of service. If you're not doing 4K video conferencing with 30 people, you don't need or live video streaming in 8K with you look at some of these cameras like these like light field cameras and these gigapixel cameras, and you look at the data rates that they're dealing with, and you say, well, we're going to need 100 gigabit Ethernet in everyone's house because everyone's going to have one of these cameras and they're going to be streaming and they're going to be downloading video, and we have like 32 audio channels now on surround sound, and then they're going to make it 128, and then we have 3D audio, and you can't even count the number of channels, and then you're doing teleoperations. So you might have a factory with robots, and the people who are operating that factory live in a different country. So the bandwidth rates that and then we have people who are life blogging, so they're just going to record everything. They're going to put like a camera on their face, and they're just going to record everything and just put it on the internet. And so you have these applications that are producing millions of terabytes of data that have latency requirements that are very small. Like if you're doing drones, for instance, we didn't have drone taxis. Now we're going to have drone taxis. If the drone has a 2-second interruption in its internet, that drone can crash, and it's a safety issue. So you need 100% reliability 100% of the time. And even small interruptions or what's called jitter, like differences in latency, become problems for these new applications. So we have 100 different applications that are just coming onto the market, and they say, we need this, and we need this, and we need this. And the current internet protocols cannot deliver what they require. And so Skywire is really looking at the future of the internet, which is where we're going to be in 10 or 20 years, and specifically how blockchain can enable that future. So we're building one networking protocol, and it has different use cases, and those use cases are, for instance, in IoT, if you have sensor data, like you have a temperature sensor in a factory, that temperature sensor will now have a CPU in it, and it can produce a CXO data feed. And then each user can subscribe to that feed, and the data replicates peer-to-peer. So if 10,000 people have to subscribe to that feed, they're not all trying to connect to this little dinky sensor that has a small CPU in it. Once one person gets a copy of the data, then they can get it from another person who has a copy, and so on. And so we can actually scale to like 1 million devices looking at some type of data feed. Whereas the current internet with a TCP connection, you can only do up to 10,000 max. And then if you need 10,000 max connections simultaneously, whereas with CXO, we have unlimited scalability horizontally. So there's little niche applications like this, and you don't really see the brick wall until you hit it. And then you say, okay, we did it with TCP, but it doesn't work. And then what works? And for a lot of these applications, especially with IoT and robotics and teleoperations and like drone taxis, where we want like 6 redundant antennas connected to 3 redundant access points for redundant, to have 3 different levels of safety and failover. These applications are not serviced by the current networking protocols.
Okay, so building out to meet these future applications, how do you actually roll out Skywire then?
So right now we've been running prototype forms of Skywire for about 4 or 5 years now. We've actually rewritten it over 15 times, and we start with just running over the internet. So the Skywire nodes are just running over an Ethernet cable. We're not even using Wi-Fi. Then we test the Wi-Fi adapter, and then after that, this new generation of Skywire is running on the Skycoin hardware platform, the Skywire miners. So we have our own hardware platform, and people look at the Skycoin miner and they say, "Why do you have 8 computers?" And the reason is they think they're going to plug this in their Comcast, cable modem, and they're going to only need 50 megabits. And the reason we have 8 computers is each computer can only handle 100 to 250 megabits per second. And we're building this to scale out to 100 gigabits per second. So you might need 60 or 80 hardware nodes just to handle the traffic. And so we started with running it on like laptops, and then we did some servers like cloud, like Docker, and then we started moving to dedicated hardware, and now we're running the test net for the Skywire miners, and that's just going to be running on the current internet. So some guy at a colo plugs it in to the existing cables, existing fiber optic. Then we're doing phase 3 deployment, and in phase 3 we're focused on physical interconnects. So we have these motorized antennas that we just started prototyping. I think they'll be ready in a month or 2. People will start getting these in the mail. And we have a 6 gigahertz Wi-Fi signal. We have like 4 independent emitting elements. So it's called MIMO, multiple input, multiple output. And this antenna has a 2-degree beam width, so it's a very tight, narrowly focused antenna that has a very long range, up to 15 kilometers. Some people may even get 50 kilometers if they put it high enough and they have line of sight. And this antenna, right now, I think it can do 150 megabits per second, but then we're doing another version which will do half a gigabit per second. And there's really no limit to how much bandwidth we can get on these. But the idea is you're gonna buy one of these antennas and you're gonna run a wire down to your basement and plug it into your Skyminer, and then this antenna actually has a motor, so you can reposition what the antenna is aimed at. So during the day, if someone installs a new antenna, your antenna can actually automatically reposition itself using this motor system that we developed. And it builds a mesh net. And this isn't like a little dinky Wi-Fi mesh net with that's going to go like 100 meters. This thing is designed for 15 kilometers with almost a gigabit per second bandwidth. And then we're going to keep upgrading it. So we're starting with a 14 centimeter antenna, and we have a motorized tracker that was designed for camera stabilizers. And we can track a 1 meter sized object from 1 kilometer away. So if you have an antenna that's 1 or 5 kilometers away, your motor on your antenna is automatically going to be able to track this. So you're going to have people that are running 30,000 nodes on Skywire. They have 30,000 ARM cards that are each running Skywire nodes, VPN nodes, Sky Messenger nodes, video streaming nodes. Whatever application you're running on the Skycoin ecosystem is going to get dedicated hardware. You're even going to be able to rent out these nodes to other people. So if someone wants storage space and you have a terabyte storage attached to your node, you can rent that out to someone for Skycoin on a monthly rate. If he's doing video editing and he needs to get like 400 computers to do his video editing fast, he'll be able to rent those by the minute. So so it's also a cloud platform. It's very similar to Golem. So there's different. So we have the computation, we have the storage, and then we have the communication. And so Skywire is going to be the first application that really focuses on the communication, and we're building the backhaul. So we're trying to figure out, you're here there's a fiber optic cable with 100 gigabits of bandwidth, and you want 1 gigabit internet connection in your home, right? And Comcast isn't going to give that to you. So we want to say, what hardware do we need to put on your roof to get you a gigabit per second internet connection for $10 a month? So that's what the Skyminer is there for. And we say, okay, the fiber optic cable is 3 kilometers away, so you might need 1 or 2 hops to get to that. So we're trying to figure out this hardware, which is very focused and directional. And then once we have this is called backhaul. Once we have the backhaul implemented, then we start focusing on, like, you have a coffee shop and you want to put a Skycoin node and a Skywire node in there, and if you have the software on your cell phone, you'll be able to go to that coffee shop and it'll just connect, and you won't have to put in any password. So this is going to be like an open access network, and wherever you are, that network will be there. And then you have different frequencies. So if you're in the coffee shop 100 feet from the access point, you could have a gigabit connection or a 100 megabit connection. But if you're in the middle of nowhere and the access point's 10 miles away, then we have to do 700 megabit or 700 megahertz. We have to have a long range antenna that's directional, and we have to use a frequency that goes through concrete and steel and that carries. And so your bandwidth might only be 40 kilobytes per second, but it's enough to have a phone call. So eventually, we see the telecom industry. Right now, we have all these wires in our house, and then we had Wi-Fi, and no one uses wires anymore. Like the new the MacBook Pro doesn't even have a port. It just there's no ports. They're getting rid of the ports. Like, everything's going wireless. So so you're looking at right now we're in between Wi-Fi and cellular stations. So the cellular stations are getting fast enough that they can replace the ISP and Comcast. So Comcast is jacking up the price, but eventually, if you can get a gigabit in your house from a cell tower, you're not going to do Comcast anymore. So their business is going away, and they're being replaced by the wireless provider. At the same time, the bandwidth, for instance, for augmented reality and for particular applications like streaming 4K video, you're looking at people needing gigabit per second connections. So there's a question of, how do you provide a gigabit per second wireless connection in every single room in a house or in a building? And so they have what's called femtocell, which is you're going to need a box in every single room in your house, basically, to achieve these data rates. And every single, in public places, you're going to need to support 10,000 people, each having their own 1 gigabit per second line, for instance, for augmented reality and video streaming and these next generation applications. And you have retinal displays. So there's people, they're going to put a retinal display in someone's face, and they're going to be walking around the city with a virtual reality overlay. And there's going to be textures for all of the augmented reality objects. And these textures, we've talked to AR companies that want to use CXO and Skywire, and they're telling us, like, we have 10 gigabytes of textures, and we need this every 30 minutes. And so their bandwidth requirements are ridiculous. They don't even know how to store the texture files for this. And they are saying that the cell phone resolution is going to be over here, and that these texture files are going to be gigabytes. So so there's this so going between wireless and what's called femtocell. This idea is that the wireless network, the Wi-Fi nodes in your house connected to your cable modem, and the cellular nodes connected to your phone, those are going to merge. And there's not going to be a ground line network and a cellular network. There's going to be one network. And so Skywire is one of the protocols that is competing to be to basically replace both the cable modem and replace the cell phone providers. And we're trying to and this wasn't possible before, I think, before blockchain. Before blockchain, you would have to have one company that charges everyone $60 a month and would install cell phone towers in every single building, every single street, and they have to collect the money from the user and then invest in the infrastructure. Now with blockchain, we can let the user own the infrastructure, put the nodes in their own house, and then we can determine who's consuming resources and who's providing it. So we can actually decentralize the utility company, because we can allocate coins and give people coins for owning and running the infrastructure, and the people using the infrastructure can pay coins. So I think the biggest application for blockchain, besides gaming, we're doing a lot in blockchain gaming, but the other big application is utility companies. And I think blockchain is going to disintermediate the utility companies. And these utility companies are not small companies. They're like $10 trillion market cap. And you look at some of the most stable, highest earning companies are electrical utility, water utility, bandwidth providers, Comcast, Verizon, and cellular. And over the next 10 years, we're going to start seeing blockchain start displacing the utility companies. So we already saw this happening, and so we said we need to do a project in that area, and that's basically what Skywire came out of.
So you talked about the different phases of rolling out Skywire, and one of the main questions we're seeing from the community right now is with regard to the most immediate phase, which is, if you want to talk about a little bit, what we're looking at in the next 2 months, which is testnet and then release of mainnet.
Yes. So the testnet, we have a mailing list now. It's over 2,000, I think almost 3,000 people now waiting for the Skyminer hardware. We have 8 nodes, and there's people making DIY miners, and they're posting these really awesome pictures, and they're basically just Raspberry Pi boards. We just put in like a cell phone processor and 2 gig of RAM, and that's one node. We're shipping out 600 of those right now. We've shipped out the first 50, and then we're shipping out another 550 in the next month. And that's our testnet. So we're going to test the software on that.
So the testnet will be entirely official Skywire miners, or do-it-yourself miners will be permitted to join as well?
We have people making really awesome miners, and we're going to white label. Everyone on the testnet is white labeled, so we have to put their public key in a whitelist. And we're going to whitelist a lot of the best DIY miners, and a lot of the, if they cause a problem, though, we're going to remove them from the whitelist. So like we have 64-bit chips in all of our miners, but some people are using 32-bit boards, and there's like an edge case where it runs out of memory and then crashes, and we're going to fix that eventually. But we're whitelisting specific hardware and specific software configurations for testing. And then after we fix the bugs with that, then we'll add additional ones, and we'll have a full-time support team filing tickets and determining the bugs and dealing with customer support. So over time, we're going to whitelist and add more people to the testnet. And then that should be ready by the end of March, we're hoping. And then the mainnet is when people start getting coins. So
can you earn in the testnet?
Yes. So basically, Skycoin's tied to bandwidth. So we don't want to say like one Skycoin is 1 gigabit of bandwidth, because people want the Skycoin price to go through the roof. They want to go $800. And if people are paying 10 cents for bandwidth and the Skycoin price shoots through the roof, then, oh, bandwidth's $800, right? People will stop using the network. It's the same problem with Ethereum, which is it's popular when it's cheap, and then the transactions go to $8 a transaction, and then no one can afford to buy kitties anymore, and it just collapses, right? So we didn't want... So what we're doing is we created a second currency called coin hours. So if you hold 10 Skycoin for 1 hour, you get 10 coin hours, and the bandwidth is priced in coin hours. So the idea here is the Skycoin price can go to infinity, and it won't affect the bandwidth prices because they'll be priced in coin hours. And there's a fixed number of coin hours created every hour. So what will happen is as the network expands from 1,000 nodes to 10,000 to 100,000 nodes, there'll be more consumption and bandwidth and economic activity, but there'll be a fixed number of coin hours being created every hour. So if the network expands 100x, the price of the coin hours will go up 100x. Just because each coin hour is now worth 100 times more resources, and the resources have a fixed cost. So, and then the Skycoin produced coin hours. So owning the Skycoin is like owning a money printing machine because the users are being paid coin hours every hour just for owning the Skycoin. And then people are buying the coin hours to use network services and store files and do video editing and play video games on blockchain. And we're using coin hours for transaction fees. And we're also building applications like Kitty Cash is a video game we're developing. And Kitty Cash is going to use coin hours for buying items and things like that. So we're going to create a lot of different uses for the coin hours. They're sort of like a gas, but you get them just for owning the Skycoin. And so what we're doing in the testnet is we're going to be paying people coin hours for running the testnet out of the dev wallet. And then we have a pool of Skycoin that is going to be used to buy back the coin hours. So you accumulate a million coin hours, and then you cash out and you use them to buy the Skycoin. So you get you might have 10,000 Skycoin in your wallet, and you save up your coin hours and you buy additional Skycoin. So it's sort of, so anyways, that's how the economy is structured, and we're going to, people ask a lot of questions about the specifics, but remember, this is the test net. This is an experiment, and we're going to change a lot of things, and we're going to see what works and what doesn't work, and so nothing is set in stone. We're going to do the best thing, basically. We're going to try A and B and C and D, and whatever works, we're going to do that, and what doesn't work, we'll do something else. So the specifics, so a lot of people are asking, like, how many coins am I going to get for bandwidth, and if I have 50 megabits connection, how many coins am I going to earn, and if I, and that's really going to depend. It's not set in stone at all.
Right. All right. Moving on to the list of community questions we got. The first one being, what differs Skycoin from Tor? Will it just be another darknet?
So Tor is slow. This Skywire is actually designed to be faster than the current internet. And Skywire has privacy features that the current internet doesn't have. So in Skywire, all your traffic's encrypted by default. And it's not like Tor. I think Tor has more privacy than Skywire. But if you want more privacy, you can layer it as an application on top of Skywire. But what Skywire does provide you is, if you're a node forwarding traffic on Skywire, right, you're worried about being sued or illegal data or something, you don't know the contents of the data because it's encrypted. So you have no liability. You don't know, you just see the bits and they're random. And only the sender and the receiver know what they're communicating. And the other thing is, each node forwards packets very similar to Tor, and you only know the previous hop and the next hop. The difference between Tor, though, is the speed is designed to be gigabits. It's designed to be up to 100 gigabits per second or higher. There's no limit on this, whereas Tor is very slow. And the latency on Skywire is going to be lower than the latency on the current internet, because what happens is the current providers aren't paid for providing traffic. So they have a thing called hot potato routing, and there's a Wikipedia article on this. Your ISP, say you send a packet from Comcast to another Comcast user on the other side of the country. Comcast could carry that packet across the network completely on its own fiber. They don't. They actually will dump the packet on whoever they can as soon as they can, because they don't want to congest their networking resources. So when they see your packet, they'll say, who can we dump this packet on? And they'll pass it on to a different ISP as soon as they can. So your packet gets passed around 30 or 50 or 80 times. You could actually send a packet to your neighbor, and you could see that packet on the current internet takes 160 hops. it goes all over the freaking place. It goes to a different state, a different country. It goes through all over the like if you do what's called trace route and actually look where your traffic's going, you'd be really surprised about how inefficient the current internet is. Skywire could be 4x faster than the current internet in terms of latency. So for video games, like if you're doing an FPS, your latency might be 30 milliseconds instead of 150. We don't actually know how fast this is going to be, but we know that the way the current internet is structured, that the way we're doing it is going to be a lot faster in terms of bandwidth and latency. And what was the question?
The question was, how is it different from Tor? It would just be a dark net.
So
also, well, as long as we're on that point, because you already kind of talked about this, additionally, how does Skywire prevent unwanted content if it's truly open and doesn't block content? Would this be up to the people running Skyminers, and are they able to stop it?
So for the Tor question, so the big difference is no one gets paid for running the Tor nodes, so it's slow. Like no one's going to give all this bandwidth for free. So Skycoin, Skywire, you're actually getting paid for providing the traffic. So if the network becomes slower, congested, some guy can make a lot of money providing that bandwidth. So as long as if the demand's there, the economic incentive in Skywire ensures that people will show up and start providing the bandwidth. That's the most important thing. The privacy, I think it improves a lot on the current internet, and it'll never be at the level of Tor. But if you wanted to build Tor on top of Skywire, it would be even more secure than Tor is now. And Tor only does 3 hops, whereas Skywire can do like 15 hops or 20 hops. So, and when we pay people to run it is another big thing. And the other thing is it's simpler. Like Tor is like 180,000 lines of code. It's very complicated, and they have a lot of security issues and unpaid developers. And Skycoin, we have more developers, and our code base is a lot simpler. And Tor was one of the major. Tor and I2P were some of the major architectural inspirations for Skywire. So there are a lot of similarities there.
Okay, so the next one, you like this kitty cache stuff.
Oh, the censorship.
Well, there's the censorship one if you want to hit that.
Yeah.
Okay.
So people ask like, terrorists are using the internet, or terrorists are using Bitcoin to buy bombs, or they're concerned about pedophilia, and they're asking questions like, I don't want this content on my computer, and am I going to get in trouble for this if I can't? So there's these questions about how censorship works. So on one hand, you want to have a free internet where people can post whatever they want, and on the other hand, there's content, and people say, I don't want this content on my computer. They don't want the legal liability. So what Skywire does is, if you see someone that is sharing child porn or something, and you just blacklist their public key. You say, I don't want to connect to that person. And so the people that are sharing this illegal content or running drug markets, there's going to be a lot fewer nodes dealing with them, and they're going to get higher bandwidth rates and more money because it's going to be over a smaller congested thing. But you say, I don't want to deal with them. So you choose not to connect to those people. And you also only replicate the content that you want. So you'll replicate your friends' feeds and the video feeds that you're watching, but if you're not using or consuming that content, you're not going to have a copy of it on your computer, is basically the way it works. And but for censorship, if people want to host the content, there's nothing we can do to stop them, basically. So there's a middle ground where people that are hosting content that's objectionable to the community, they're going to have a hard time finding peers, and there's going to be a limited number of people that will connect to them. And the other thing, to protect people for legal liability, we have end-to-end encryption. So for instance, you can have a court order with an ISP, and the ISP says, the court says, block this website. On Skywire, you only know the previous hop and the next hop, and you don't know the content. So if someone gives you a court order and says, block this, you say, I can't do that, because you don't know who the traffic's from, and you don't know where it's going to, and you can't read its content because it's encrypted. So we've basically eliminated the legal liability problems that a lot of people have, for instance, running a Tor exit node. If you have a Tor exit node, people are using your internet connection, and you run it on your house, and someone downloads child porn, and you get raided by a SWAT team, and they said, you downloaded this child porn, and you're like, no, I'm running a Tor node, blah, 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 and you have to explain to them for 20 hours what Tor is and blah blah blah, and you're not sure if you're gonna get prosecuted, and the SWAT team shot your dog, and and your dog's dead. And anyways, so we fix these problems just by the way we design the protocol. And I think that's very important for these next generation internet projects.
No dead dogs with
Yeah.
Skywire. Okay, so the next one is about Kitty Cash. You made a comment in the Telegram that Kitty Cash, once it comes out, is going to burn all the coin hours, and people were confused why that would be and what that meant. So why will Kitty Cash burn any coin hours?
So we think that video games are the next $1 trillion industry on blockchain, and that's one of the areas we're focused on. And one of our pilot games is Kitty Cash. So the more uses coin hours have, and the more uses Skycoin have, the higher the price will be, of course, and the more adoption it'll have. So we try to build applications in the ecosystem that create uses for Skycoin. So people give us money like OTC, and then we go and hire 40 developers, and each of those developers works 24/7, like 18 hours a day to build applications to make Skycoin worth more money. So what we're doing is Kitty Cash and these games we're building and these distributed exchanges we're building, they're going to be using Skycoin coin hours as their currency. So there's going to be a lot of uses for Skycoin coin hours, and the more people are using coin hours and the more uses and utility those coin hours have, the more Skycoin will be worth. So that's basically our philosophy on how we decide whether to do a project is, can it get a lot of users? Will this create new uses for coin hours, and will this be useful to people? So Kitty Cash is our version of CryptoKitties, basically, but it's gonna be completely over the top. This is gonna be a really fun game. We're gonna basically there's a game called CryptoKitties on Ethereum, and Ethereum can only do 30 transactions per second. And so when this game became very popular on Ethereum, and when 30 people were buying and selling and breeding kitties at the same time, it clogged the whole Ethereum network, because every single application on Ethereum has to share the same blockchain. In Skycoin, we give every application its own blockchain, so that if one application becomes popular, it doesn't shut down all the other apps on the network for 4 days. So we have a horizontally scalable blockchain platform that solves a lot of the scaling issues and transaction throughput. So in Kitty Cash, if 30 people were buying, selling, and breeding cats at the same time, Ethereum was basically shut down for days because of these cats and people breeding the cats. And the cats were people were buying and selling the cats for $600,000 and then breeding the cats and then selling the children for like $10,000, $20,000. So there was a cat mania, and everyone's getting rich breeding and buying and selling these cats. So we really liked that game, and that was really the first time we saw a video game on blockchain, and we said we want this for our platform. So we started funding video game development and sort of moving in that direction. And so in Kitty Cash, you have to feed the cats, or they die, or they'll complain. You're going to be able to send cats to a Skycoin address, and you're going to be able to give your friends cats like as gifts. You're going to be able to breed the cats. They're going to be like Tamagotchis. The cats are going to have weapons. We're currently like doing mini games, like cell phone games, and your cats can die and they explode and like coins come out like a piñata. And so we have population control on our cats because we don't want to like the population to increase too much. We want to keep the cats scarce. We have the Kitty Cash is going to be massive. I think we're going to have 30 developers on that. And we're getting like 2 offices and like 6 or 8 external parties making like mobile games, Kitty Cash tower defense. We have Kitty Cash t-shirts, Kitty Cash stickers, Kitty Cash hats, Kitty Cash bumper stickers, Kitty Cash hardware wallet. We're going to be printing up like cards and we're handing out like 100,000 cat cards at like conferences, and you're going to be able to scratch off a code and scan the code with the Skycoin mobile wallet to get the cat in your wallet. And you're going to breed the cats with the Skycoin coin hours, and then you're going to be able to like send your extra cats to your friends as gifts. And and this is going to be crazy. And the Kitty Cash, we have what's called, so we have the initial cat offering, the ICO, and then we have for rare cats aren't fungible. So Kitty Cash is the first non-fungible asset that we're putting in the Skycoin wallet. So one cat is not equal to another cat because it's a different age and it has different attributes and items, whereas one Bitcoin is the same as any other Bitcoin, so they're fungible. Kitty Cash are non-fungible assets, so after this, we can start putting gift cards into the Skycoin wallet, like coffee gift cards or coupons or get a free, Groupon offers. We can start putting things in the Skycoin wallet that are non-fungible. So that's really exciting just on the technology level. But in Kitty Cash, so you have this cat, and he's non-fungible, but the cat might be worth $300,000. So you want to have an ICO or initial cat offering, and you start creating shares in the cat. And if you own the most shares in that cat, you're the owner, and you have to feed them and breed the cat, and you own the cat. But other people can speculate on the price of the cat. And then we have, so then you have a cat that now has a share. So we take a non-fungible asset and we make it fungible, and we put it on a stock market. And then you can have a asset manager come in, and he can start buying up portfolios of cats. And so he's I forget what this was called, but he's basically a manager that buys takes your money, you give him 10 Bitcoin, he buys cats, and he creates a fund called the Cat Traded Fund. And he might have 200 cats in his fund, and he breeds the cats and sells the cats and buys the cats. And then you can buy shares in the Cat Traded Fund, the CTF. And then you can do futures and derivatives on the CTF funds. So so you can do like 50x leverage on a CTF fund, and so this is like a stock market real trading game. And then we're gonna have mini games where you have like a cell phone app, and then you can win items for your cats, and then you have auction house and a money tree. And this is gonna be a lot like what was that game that was popular in the 90s?
Are you talking about
with the money tree? Are you shaking the
I
money
don't
tree?
know.
This is before. Anyways, like DigiPets. I forget what it's called. But there was this really fun browser game, and that's what we're trying to do with Kitty Cash. And this is basically a lot of the coin hours I think are going to be spent on these games, and eventually blockchain poker and card games, and we're going to have a whole bunch of games. This is just really a prototype.
Okay, so the next thing is, will you guys work to be able to store the coins in a nano ledger?
Yes. I think someone or someone related to them contacted us, and we're working on integration right now with 3 hardware wallets. We're also releasing our own hardware wallet. So we have the Skywire, we have our own hardware platform, and we also are going to, of course, have our own hardware wallet, which we're currently hiring developers, and we're trying to get that into production. But right now, for hardware projects, Skywire, and then the antenna will ship, and then after the antenna ships, then we're going to start looking at setting up the factory for producing the hardware wallets. I think our wallet, though, we want altcoins for the masses. So we want to be able to store every Skyledger coin. We want to be able to support a couple dozen top coins, and we want our wallet to be $10 or $15. We don't want to have we don't want a $100 wallet. We want to make the wallets as cheap as possible. We want to give them out like candy, because I think hardware wallet is the only secure way of storing your coins. Especially as altcoins become popular, you're gonna see grandma trying to buy coins, and she has like a ad banner thing. She clicked the wrong button on her web browser, and her computer is getting all these ads, and her coins just get stolen. So without the hardware wallet, I don't think that we're gonna have any type of mass adoption of Bitcoin. So for Skycoin, it's really imperative that we get our own hardware wallet out, and we get it out soon. And the mobile wallet, of course, and the hardware wallet costs $10. So, and then if we can get to $5, we're going to do that.
Okay. Staying on the topic of hardware, we got a question: can I modify a Gen 1 miner for long-range Wi-Fi?
Yes. So we have a custom OpenWRT router with 16 ports, and you're just going to plug in take your antenna and plug in an Ethernet cable to that thing, and then put the antenna on your roof or wherever you want to put it. And if you have a fiber optic cable, you'll do the same thing. You just plug in whatever mode of bandwidth or transport you want, and it just works. So the Skyminer, those nodes are the hardware for processing the backend and the VPN and the packet forwarding and running the blockchains. It doesn't really care how the packets are transported. You can plug an antenna in or a gigabit fiber optic cable, and the protocol has what's called pluggable transport. So it doesn't actually care what carries the data. So we abstracted the interface layer to get rid of a lot of anyways, you'll see that it's a very specific question.
Okay, the next one is, should we buy Orange Pis, and which ones if so?
Any 64-bit ARM processor or computer that can run 64-bit programs will work now. We are going to test 32-bit, and we're going to test with 512 meg of RAM. And we're going to test like quad core, like 8 core with 8 gig of RAM, and we're testing some high-end chips that have like PCIe buses, and we're actually looking at, they have like PCIe router chips. So we're looking at like if can I plug in 128 hard disks on PCIe, like M3 like SSD chips, and make like a giant box that can store like 100 terabytes or something. Can I do that? And we're looking at different ways of expanding the miner and different hardware attachments. So right now we're just focusing on getting that our custom OpenWRT router built, and that's going to be done in a week. We're going to get the first prototypes back and then start manufacturing. And then the second generation miner is going to be using that new OpenWRT router board we just had made. And then we're going to add the antenna, and then we're going to start, Spaco is doing storage, so they want hardware attachments for storage. So then we're going to look at how do we connect like a PCIe M3 storage array so that we can do like network attached storage, and how do we do that? And so we're going to be continuously upgrading. By the time you get your Skyminer, it's basically obsolete. By the time it's packaged, we have the next version coming out. And for Skywire, we also have people working on FPGA. So the software isn't even done for the Skywire. And we have these people, and they're going to have one chip. And that chip is going to be able to process it's going to be able to process as much traffic as 30 or 60 ARM processors. So you're going to get your Skywire and plug it in, and then in 3 months or so, whenever we have this ready, you're going to have an FPGA miner out, and everyone's going to have to upgrade because the FPGA miner is going to be 60 times as powerful. And as soon as the antenna's ready, of course, we got 150 megabit. As soon as it is shipping, we're going to be trying to upgrade it to 500 megabit, and we're going to be going from 1 antenna to 6 antennas, and it's never going to stop. It's just like the Bitcoin miner. You buy the Bitcoin miner, you run it for 2 weeks, and then the new miner's out that's 50 times more powerful.
Right. Now, so with regard to that and the different generations and the iterations of the equipment, how do the first 300 official miners that we're rolling out right now differ from do-it-yourself miners and later generations of miners in terms of the rewards?
So I think, they have different hardware, and the testnet, the purpose is testing. So of course we're going to do DIY miners, but we want to know what hardware you're using. Is it 32-bit? Are you using Ubuntu, or are you using CentOS, or are you using this other thing? And if there's an operating system like L4 Linux, we want our own distribution. We want Alpine Linux running on this. They might need to do kernel drivers or something, and I want to know, does it work? So we're going to give these people like a lot of coins rewards for testing out this other hardware that we want to move to in the future. And then once it's working, then we'll start shipping official miners with that hardware. So there's a lot of things we wanted to get into the first gen that we couldn't. So if you're testnet and you're testing specific hardware configurations and software configurations that we want data on, we're going to give you a huge reward for that, of course. And if you're finding a new way of making the Skyminers cheaper and more efficient, and we're going to start giving bounty program rewards we're collecting pictures of all the DIY miners, and we're distributing rewards to everyone building DIY miners. And but we need to whitelist the node. We need to know what hardware you're running, the software, there's information we're trying to collect so that we know, that node had a problem, and then we can look at what operating system and see if it's something common to that hardware. How much RAM does it have? What is the reliability of different, we want to track that data basically so that we can get some feedback and give it to the support teams. The rewards, I think the people paid like 1 Bitcoin for the miner, and they got a bunch of Skycoin back, but so we're going to make sure they get a lot of rewards, of course. By the time, and they're going to get their money back like a couple times over, of course. The miner, the miner's so expensive, and you pay $15,000 for the miner, or $45,000, but then you make $150,000 of Bitcoin in the first week, right? And that's typically normal for mining rewards. I think everyone that is in before the like 6,000th or 10,000th miner is going to be baller. I think that they are. I actually looked at the formula about how many coins we have allocated for distribution over the first year and how many miners we currently have in the queue, and the mining reward is going to be obscene. People are going to be jealous and angry. They're going to be stealing Skycoin miners, basically. They're breaking the houses and stealing Skycoin miners. It's going to, you got a Skycoin miner? Oh, he has a Skycoin miner. Let's go break into his house and grab it's going to be pretty crazy. I think to really scale the network, though, we are going to, all of the DIY miners are going to be whitelisted. and they're going to basically eventually get the same mining rewards. So there's two types of mining rewards. There's mining rewards coming from the developer wallet. We're going to fund the rollout of the network. And then that's where the obscene money is coming from. Then there's mining rewards from adoption. If we're building a network over a whole city like San Francisco, we're going to have 100,000 nodes. So there's no way that we can produce that. They're going to have to be DIY miners. We're going to have 6 or 8 companies like partners, like Bitseed, like Mike from Bitseed, one of the founders of Arc, is starting his own factory to produce these nodes, apparently. So there are going to be people building specialized hardware. Like this company does the antenna. This one does storage arrays. This one does cases. This one does Skyminer platinum power supplies. This one does M3 storage arrays. This one does the antenna, silver. I was joking about like the, silver, these things are so expensive and the rewards are so obscene. It's like, why don't you just get silver wire for the antenna feed? And why don't you cryogen treat it too? Like they pour like liquid nitrogen, the autophiles like get silver wire and then pour liquid nitrogen on it because they think it makes it sound better. I'm like, okay, whatever. Because the mining rewards are so obscene that no engineering cost should basically be spared. Like we have a huge budget just for custom PCB boards, and we're gonna get our own ARM boards, and we're getting our own antenna. I'm going to the machine shop, and they're getting like this huge stainless steel disc, and they put the disc on a lathe, and then they form the disc into an antenna. So we're going to have 18 different antenna designs with different antenna feeder elements, and we're going to test every single one of them. We have like custom factory, like a company that just takes the metal disc and makes our satellite dish. So we're going to try 14 centimeter, 17 centimeter, 21 centimeter. We're going to try different frequencies. We're going to have our own, and so there's going to be 1,000 different variants of mining equipment. So to say, like, is the DIY miner going to get the same reward as the... It depends on the... We're going to try to make the miners we're shipping the best, and we're going to continually upgrade them constantly. And the newest hardware is always going to be on the ones we're shipping. But the DIY miner, of course, it's going to get rewards based on its performance. So it just depends. But then we looked, and if you go from the first guy with the FPGA miner is going to have one box, and he's going to make 30 times more than... Like you're gonna need 30 Skyminers to basically match one chip on the FPGA miner. So the mining is going to advance very rapidly. The people are going to constantly have to upgrade their equipment to the best equipment, and the way Skywire works is there's never enough equipment. Like if you have 300 nodes, if you do 10 times as many nodes, you're going to get 10 times the money, 10 times the rewards from the network. So there's the scale. One of the things we're worried about is, can we actually handle 1 million nodes on this network? And right now it can't. We can only handle 3,000 nodes or 6,000 nodes before our current infrastructure collapses. And we have to have a whole team just doing analytics and monitoring like transactions per second and figuring out what our overhead is and scaling out the network. So we're actually terrified that this thing will grow too fast, and that we won't, and that our existing, for instance, there's a thing for sending messages between nodes, and it only can handle 6,000 connections right now. So if we have too many miners on like 100,000 miners go on the network all at once, it's going to collapse. So that's why we're doing a whitelisting process, and then it's going to take them a month to build out the next generation messaging infrastructure that'll scale to 10 million. And then when we get to 10 million nodes, then we have to do another. So it's constant upgrades. It's never done. As soon as we finish one thing, we go to the next thing.
Okay, so the next question is, were there unofficial test nets during the construction of the miners, and if so, what was the utilized bandwidth consumption of one miner?
So if you're on a VPN, right? The first real application for Skywire is we had this VPN, which is awesome. This is probably the fastest VPN that has ever existed on Earth. You can have 25 connections to the same server going over different paths. We had you go through the firewall in China and it's like 300 kilobytes per second or something, or you get like 1 megabyte. If you pay $50 a month for like a really good VPN, and it's not necessarily reliable, and it goes in and out depending on what city you're in. This VPN we've tested was getting like 50 megabits per second in some third tier city. It was it uses all available bandwidth paths. It's faster than anything that we've seen before, and we've maxed out the hardware basically. Like the CPU couldn't it could go faster, but the CPU couldn't decrypt it. So we're probably going to actually have a hardware box with like an FPGA in it, and we might be able to push like 500 megabits per second through the VPN. This will probably be faster than your normal internet. It's so the bandwidth saturation, I don't know. We've done over 25 megabits and 50 megabits, and there's no limit, basically. So if each card can handle only 70 megabits per second and you have 10 cards, you could do 700 megabits. So we decided, instead of having one giant massive computer, to have really small cell phone processors. And if you want double the speed, you do 2 processors. And if you want 8 times the speed, you do 8 processors. And our architecture is designed so that there's no scaling limit. If you need 1,000 processors, you can do it. There's no reason. It horizontally scales. You're going to hit limits on your laptop and what the application can decode before you hit the limits on Skywire. And this is very interesting because we had video companies, and they're doing like video renders, and they have like 100 terabytes of data, and they want to send it in like 5 minutes, and they're complaining that the routers are maxed out and they can't get the data fast enough, and they really want to have 10 wires, and they'll install 10 wires with the current internet, and there's something called route flapping. It'll only use one of the wires, and then when it's full, it switches, all the traffic goes to the second wire, and then when it's full, it goes to the 7th wire. It can't the current internet, IP version 6, is not designed to use all available bandwidth paths. Skywire is the first application, first type of networking protocol that can, if you have 10 lines, it'll use all 10 lines. It'll max all of them out. So this is really, and the user doesn't even know they're using Skywire. So this is plumbing. Like when you're on YouTube, you don't know if it's TCP or UDP or what CDN YouTube's using. All of this is going to be in the background. The people using Skywire in their application, 90% of these users will not even know they're using Skywire. It's just going to be, the user is mostly going to interact with the application, like the social media app or the Kitty Cash or the wallet or the exchange, or they're going to be using the Skywire VPN. So the user is mostly going to be focused on the application, and then the miners are more concerned with the back end.
So the final question we got really plays into what you're talking about here, which is, how will the network transition from piggybacking off existing infrastructure into a fully independent mesh network?
So we have what's called wireless internet service providers, and they have like 300, 400 customers, and they'll run a fiber line, put some antennas on the roof, and they'll rent out like 300 megabit, 1 gigabit per second lines to each person, and they send it point to point over wireless. And these are proliferating, and there's very large companies like Ubiquiti, and their whole market is just providing hardware for these wireless internet service providers. So Skywire is basically an open access wireless internet service provider. So we're going to start with just using the backbone and the co-location centers, and we have some very, very, very large partners. As soon as we announced that we're doing this, we had like literally state-owned there's a state, like a country, and there's a telecom, and the president's friend runs the state-owned telecom, and he's a big Bitcoin miner, and he's like and they have like their own VPNs and their own servers for the government, and he uses the spare servers for like mining apparently, and then this is a revenue center, so the state telecom only loses money, and they always they lose money, and the government taxes people and bails them out every year, and then now they're making money on the Bitcoin mining. It's like a profit center, and they come in and they say, yeah, we got 300 terabytes, blah 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 blah, and we want to run these miners. Can you send us 3,000 Skywire miners? And I'm like, no. And so we're getting all these weird people, like very very like telecom, VR, AR companies saying, how do we stream 20 gigabytes of texture data to someone on their cell phone? Can your thing do that? Augmented reality companies, teleoperation companies, video companies doing video rendering with like 100 terabyte data sets they want moved over the network in like 5 minutes. It's like to the render farm, because they have 20 campuses, and then they have a render farm, and they're trying to move the data between the campuses and the render farm, and then get the video feedback, and they're sitting there for 4 days waiting for their videos to stream, and they installed 10 cables, and they found out that only 1 cable is being used at the time, and 10 cables wasn't faster than 2 cables. So they're like, what the hell's going on here? And then they find out that it only uses 1 at a time. So so we have all these people coming to us, and what's the question?
The question was, how do you get Skywire from piggybacking off the existing infrastructure to fully independent mesh network?
So we're going to start with just running over cable modems and running with fiber optic cables, and then we're going to start building up backhaul, which is long distance point-to-point fiber. And Facebook, Google, and a bunch of large companies are already experimenting with this. Like Facebook has like a 40 terahertz phased array antenna, like femtocell technology and so on. And Google's experimenting with blimps, and we're sort of in that market. But the difference, we're sort of an open access protocol. So if Google does something, Facebook and Microsoft and Time Warner and all these companies will block it. And if Google does this, the other companies will block it. But we're an open protocol, so it's not sort of threatening to they can still use the protocol internally, and it's not owned or controlled by anyone. So it's a lot less like all these companies want this technology, but they're sort of threatened because they don't want anyone else to actually own all the patents or control it. So that to really build this next generation internet, it needs to be by consensus of multiple large companies and hardware providers and end case users, and they really want open protocols. They don't want something like owned by Cisco or something. And they've had a lot, and the government too, like the military will install this system, and it's an MPLS, and then it costs them $10 billion, and then they end up paying $80 billion, and they have all these problems, and they never get fixed because of the support cost. And so these companies, so the government said we're not going to get raped again. We're going to go to open standards. So they funded this thing called Open Flow, and they had Google and the Stanford Research Institute and the military, government, Pentagon, Google, everyone. They pay Google. DoD gives Google money, and then Google takes something out of Stanford, and then they fund and develop it, and then there's a consortium of large companies that then adopt it, and they feel like no one is going to control them and screw them over in the future. So the future of these networking protocols for IoT, especially in augmented reality, it has to be an open standard, and it has to be, so we're providing that network, like the patch cables and the backend protocol, and then we're going to have multiple hardware providers. And so if Ubiquiti wants to come in on this and they want to make Ubiquiti Skycoin native, they're able to use Ubiquiti hardware. So they benefit because they get to sell their equipment, and they get to make it plug and play and support the customer service and sell more hardware, and we benefit because it promotes the Skycoin ecosystem. So there's different companies and different partnerships that we're looking at. And we're also doing it internally. So if one of these large companies doesn't come up and do it and make their own PCBs, we're going to have our own PCB boards and our own wireless chipsets and our own. We're not waiting for them. But so the initial rollout is we just piggyback on the existing internet, and then we just focus. We're not building transatlantic cables. We're not launching satellites. Actually, when Skycoin gets to $1 billion, we're all launching a satellite, but it's mostly for marketing. It's not actually going to be, yeah. We're not laying transatlantic cables. What we're doing is we're only the real application. 95% of the cost for the network is in the last mile. It's in the last 5 kilometers between the fiber optic cables and the user's house. So we're really focused on that 5 miles. We're not really focused on how do we put satellites in orbit and build a global network. And because there's other companies that are going to do that, and once the bandwidth's in place, they can use the Skywire protocol and monetize their bandwidth through us. So we don't really, if you have a transatlantic cable and you have spare capacity, the owner can actually rent out the capacity and make money on Skywire, and they'll do that. So we don't really need to run another transatlantic cable. And we also, one of the major benefits is we allow users to monetize unused bandwidth. So a corporate customer needs 1 gigabit per second dedicated, but they don't use it. So now they can put a box in place, and if they have spare bandwidth, they can monetize their bandwidth. So we're really creating a market for this unused bandwidth at the ISPs, and they're really excited about that too. And even people that you would think we're actually competing with them, and I say, like, we're going to destroy them, we're going to bury them, we're going to take that company to the grave, right? And if we succeed, we will. But that company is also coming to us and asking us how they can use this technology to monetize their spare bandwidth, and they're very so it's very ironic. There's really is no competition. It's just been a lot of cooperation, and even companies we thought that would oppose this for various political reasons are actually supporting it.
Okay, well, that was the last question. Closing out, if you want to quickly state, what is the ultimate vision of Skycoin, and where do you see it in 5 years?
So Skycoin is a huge project. It's not even just a coin, it's an ecosystem. We have video games in development, we have a hardware platform, mobile wallet, desktop wallet, antenna. We have our own PCB boards. We have our own router. We have like video games in development. We have our own video game platform. We have our own platform for companies launching coins. We have Skycoin is. The thing is, we don't know what's going to succeed. We'll do 80 projects, and 4 or 5 of them will succeed. And we are just, blockchain is still very early. No one knows what the killer application was. So the idea between Skycoin is, instead of doing 50 coins, and you buy this coin or that coin or that coin, and this coin will do IoT, and that coin will do video streaming, and that coin will do video games, and that, the idea was to put all of this stuff, all the applications under one ecosystem with one coin. So Skycoin really replaces 80 or 50 coins, and we feel like people are going to get sick of having 120 different coins. Like, this is the coin for instant pay. You pay instant messages. You use this to pay instant messaging. It's one instant message per coin. This is your video streaming coin. This is your social media coin. This is your blogger coin. This is your distributed exchange coin. This is the coin you use to store files. This is your bandwidth coin. This is your video game coin for this poker site. This is your, it doesn't make sense. I think we need to have one coin that can, eventually we're going to see a platform emerge that replaces 150 different coins with a single currency and a single platform that captures all of the utility of these little widget coins. And I think that platform is Skycoin. That's what we're basically building. That's why we're high, like, we have 150 people, and it's like we're going to triple that. And then we're going to have 450 people. And then we're going to have 30 people on Kitty Cash. And then we're going to have 9 video game development teams of 3 to 5 people. So 40 people doing video game development and releasing a new game every 3 months. And we're going to have 18 hardware teams. And we're just going to steamroll them. Is basically, we have a platform strategy, because we believe that you have to have an economy of scale. You have to, and then we're launching partners on our platform. So we have utility companies, like 6 utility companies. And if you have 6 utility companies on your platform, then when the 7th and 8th company come in, they'll say, what is everyone else using? Oh, they're using Skycoin. So Skycoin becomes the standard, and we don't monetize them. We don't charge them Skycoin, but they come in and they use Skyledger. They use our hardware. We help them. And then we do joint marketing. So when they get in Forbes or Barron's, or they're on the cover of Wired magazine, it's like, this was built on Skywire and this was built on Skycoin. And so we're really trying to build a juggernaut. We're not building a widget coin. And I think as the market matures, a lot of these widget coins, like Instant Messenger coin might be worth $1 billion today. But if Instant Messenger coin is just a feature of the Skycoin platform, or a more successful, better organized, better funded coin, I think that it'll work for now. But in the future, we're going to, like, if you look at Google, like, they have 500 projects. So we're trying to sort of be like a Google or like a Yahoo. Like, we have one brand, and we have multiple development teams and multiple engineering teams, and we have multiple services that we're offering under one umbrella. And I think that's ultimately more convenient for the user. And I think that people are starting to get sick of having 600 wallets on their computer. It's just do you really need 600 coins in your life? So over time, the market's going to consolidate into a couple dozen really big coins. So Skycoin also, like privacy coin, like we also have the privacy feature. And we don't say Skycoin's a privacy feature coin. It's just a little feature. It's just like one thing of 40 things that we're doing. And if we go and we decide to do like a privacy coin, we say that we're going to be the best. So we make sure that we take the best technology, and we look at the other coins, and we take the best of every other coin, and then we integrate that into Skycoin. And Skycoin is not one thing. It's not static. It's constantly improving. So we could say that we're weak in this area today, but we'll just hire 30 more people, and we'll be the best in that area, and if we need to be. So we don't have a fixed anything. Everything is a moving target, and everything is constantly being improved. And if we don't have the best mobile wallet, we'll go and hire 6 teams, and we'll see who can produce a better mobile wallet than the best mobile wallet that currently exists, and then we'll use that one. So we're not really. So Skycoin is diversified in terms of we're not relying on any single project to carry Skycoin. So we have 1 or 2 flagship projects, but if those fail, we have another 6 or 8 projects ready to go that could be rolled out in 2 months. So it just, the problem we really have is that the blockchain is so early that everything can be done, and we really have to focus on 1 or 2 or 3 big things. Blockchain is still very early, and so we can do everything, but we don't. And in reality, we don't do that. We focus on the 1 or 2 or 3 things that are going to get us into the top 10, and we focus on what we have to do to. And we're also focused. For instance, CX is a programming language. It's not a smart contract language, because we're focused on what people actually use. So messaging apps are big. You can have 1 billion people on a messaging app. So we think blockchain messaging is going to be huge. And we decided to create a programming language. So CX, for instance, is not a smart contract language. It's a programming language because the applications people really want are like video games, instant messaging, social media, and we needed you can't do those on a smart contract platform. So Ethereum is cool as a demonstration, but these platforms are just first generation. They're very limited. And we want to see what build a platform that's going to allow people to see what the full potential of blockchain is going to be like 5-10 years from now. We want to see blockchain replacing everything that people are doing on Google and Facebook and Twitter and social media. And I think that every application that people are currently using is going to be on blockchain eventually. And we want to build a platform that's going to support those applications. And so that's their 5-year vision is really that.
All right, great. I think we covered all your top questions on Skywire. We'll probably do another one of these in the future, but for now, this is all.
Yes.
All right, great.